All right, in this section 11-3, the topic here is going to be arc length and sector area. And so the first thing that we need to talk about here is we've already kind of discussed an arc, right? So an arc is a piece of a circle. We learned that from the other section. And the thing that we need to remember is arc length is not the same as degree measure. So the degree measure of this arc could be 80 degrees, but the length of the arc could be 5 centimeters. They're two different measurements, so keep that in mind at the very beginning. Now another word we come to is sector. So sector is the region that's bounded by a central angle and its arc. So if this is the central angle and this is the arc, this shaded part is the region of the circle that's bounded by the central angle and the arc, and then therefore that is a sector. So the difference, and by the way, here's the notation, sector BAC is what you would call it. Okay, so the arc is this part of the circle. The sector is this region. So if you were thinking about it like a pizza, the arc would be the crust of the pizza, and then the sector would be the whole slice. All right, so that's one way that you can think about it. Now we come to two formulas. One is the formula for the arc length, in other words, the length of the arc. Okay, and it's x over 360 times 2 pi r. Because remember, 2 pi r, as we learned in the last section, was the circumference, right? Well, the arc length is a piece of the circumference. What piece of the circumference? Whatever degree measure it is out of 360. So if this is 80 degrees out of 360, then the arc length would be 80 out of 360 times the circumference. Sector area, it's the same idea. What's the area of a circle? Pi r squared. What's the area of the sector? However many degrees that it takes up out of 360 times pi r squared. So x is the degree measure of the arc, right? So if we're trying to find the length of arc AB in the area of sector BAC, then in order to find the length of the arc BC, arc length, we'll use this formula. It's x over 360. All right, remember, x is the degree measure. And remember what we said in the previous section as well. If the central angle is 80 degrees, then the arc that it goes to is also 80 degrees. And so what goes in for x? 80. So it would be 80 over 360 times 2 pi times the radius is 15. All right. And if we take all that and put it into our calculator, let's see what we get. Let's see. So if I go 80 over 360 times 2 pi times 15, there's your answer, 20.94. And so that would be the length of arc BC. So notice, the degree measure of arc BC is 80 degrees, but the length is 20.94 feet or centimeters, whatever the units are. All right, so notice there are two different measurements, and that's the first thing that we said. Okay, so the degree measure, 80 degrees, but the length of the arc is 20.94. Okay, what about the area of the sector BAC? What's the area formula? X over 360. The x is still 80 degrees, so that's 80 over 360 times the rest of the formula, which is pi r squared. So that would be pi times the radius, 15 squared. So once you've got the formula plugged in, the rest is a matter of plugging numbers into a calculator. All right. So we'll go 180 over 360. I'll just leave that exactly the way it is. Times pi times 15 squared. And then there you go. The area of that sector is 157.08. Okay. All right. So what are the type of questions that we're going to be looking at here? And so one of them says the diameter of circle A is 24. Find the arc length and the area of the sector bounded by the given arc and central angle. Okay, so again, all right, so I want to find, okay, the length of arc BC and the area of the sector that's bounded by this arc and this central angle. All right, so two things to find. So arc BC. So arc BC is here to here. I need to find the length of that arc. Okay. So now when we're looking at this, then we come through and we say, all right, so number one, we know that the diameter is 24. So if the diameter is 24, then my radius is going to be half of that, which is 12. And so I need to figure out, first of all, when I go to plug in for the arc length, x over 360. That's the first thing I need to find, is x over 360. And so my x is going to be the measure of BAC. BAC, the measure of BAC is 68. So that's 68 degrees for that central angle, which means the arc is 68. So it's going to be 68 over 360 times. The rest of the formula is 2 pi r. So it'll be 2 pi times the radius. And once again, if the diameter is 24, the radius is going to be 12. So from there, we type that into the calculator, and then we'll come up with 14.24. So that's the length of arc BC. Now we also want to find the area of the sector bounded by this arc and the central angle, right, which is here. So again, sector area is x over 360 times 2 pi r. It's the same x, so it'll be 68 over 360 times pi times the radius, which is 12 squared. Once again, once you get it to here, it's just going to be a matter of taking it and plugging it into a calculator. And when you do on this one, you'll get 85.45. Okay? So on these problems, the main thing is pick the right formula, get the right central angle here, and get the right radius here. If you do that, then you'll be in good shape. Okay? All right, the next one. We're looking for arc CD. If the measure of CAD is 42 degrees. All right, so that central angle is 42 degrees, which means x is going to be 42. So there's 42 over 360 times 42 over 360 times 2 pi times r. The radius again, still 12. So 12 goes here. And we multiply that out, and we would get 8.8 as a correct answer, so you can verify that. The next formula, 42 over 360 times pi r squared, right? So pi times the radius is still 12, squared this time. And if we were to take that and plug it into the calculator, we would come up with 52.78. Okay. And then one more practice problem. It's already written out for you here. So I want to find the length of arc DE if the measure of DAE is 148. DAE 148. All right. So that means it's going to be 148 over 360 times 2 pi times the same radius of 12. When we plug that in, we get 31. And again, for the area of the sector, it's still 148 over 360, but the rest of the formula is times pi times 12 squared. The radius is still squared, or the radius is still 12, and then that'll give you 185.98. So like I say, make sure you're getting the right formula, whether it asks you for the arc length or the sector area. Make sure you get the degree measure of the arc correct here for x, and then get the radius correct here. And from there, it's just a matter of typing into a calculator and pressing enter, and you got it.